Hello everyone. Today we are going to look at a question called subarray sums 1. This is from our CSET problem set. So this question has another variation called subarray sums 2, which we'll cover maybe in the next video or at the end of this video. Uh, so there's a slight change. So for understanding subarray sums 2, you definitely need to understand subarray sums 1 to understand that what is the change, right? What we need to do is we need, like, we are given a particular array and we need to tell that how many subarrays. We need to tell the count of the number of subarrays that have sum as x. So like if you have this particular subarray and I tell you to find sum equal to 6, right? So this is 1, this is 1, 1 2 3. This is sum equal to 6. Do you find any other subarray? Probably no, right? There's no other subarray. So like if I tell you 2 4 1 2 7, so this is 1, this is 1, and this is 1. So there are three subarrays that have sum equal to 7, right? So that is what you need to find the number of subarrays. So what is the naive approach that you would use? Like if I just give you this subarray, so your naive approach would be that let's just take I here. So you will just iterate through it, and you will basically start pushing your j, maybe from here, like from I plus 1 you will start pushing your j, and j will also go till n. So like first you will, let's say, fix I at 2, right? So like you will write like this, that I equal to 0, I less than n, I plus plus, and then maybe take another j loop which will start from I plus 1. So basically your j is here, and then what you will do is, like for each of these j you will have to compute the sum, right? Like sum of this, okay, then sum of this, and then sum of this, and then sum of this, right? And then your I will come here, so you will figure out the sum of this, then this, then this. So that is how you will do. So basically in this j loop you will need another k loop to figure out the sum, right? So if you talk about the complexity, it is so you have three loops and both are going from, like, sum is going from 0 to n, j loop is going from 1 to n, and your k loop also the same, right? So basically it would be a O of n cube solution, and n is very large, okay? So let's say for n is 10 to the power 5, right? Or let's say 2 into 10 to the power 5, so you can't fit the solution, right? uh, so therefore, what is the other way to think about? So one modification that you can do is just change this particular k loop. You can change. How do you do that? So let's say I have, let me take this particular example only, 2 4 1 2 7, right? So I can just make a prefix sums array, and I can so the prefix sums array would be 0 2 6 7 9 and 16, right? So this would be my prefix sums array. uh, so now what I can do is, when my I is here, so like my I was here at first, right? And my j started from I plus 1, right? So I don't need to figure out the sum everywhere. I can just keep moving the j from here to here, and you can just keep storing the prefix sums, and you would get the sum of each subarray from the prefix sum itself. So like from like let's say if I were to figure out the sum of this particular subarray, so I can just do prefix of j minus prefix of I, right? Just let me check once. Let's say your I is at 1 and your j is starting from here, so your j will go from 2 to 4, right? So if I were to figure out the sum of this subarray, so then it would be so my prefix, my 7, minus this. So basically it is prefix of your I is here na, so it is prefix of, and basically your prefix of 0 is 0, this is actually prefix of 1. So prefix of and this is I is 1 only, so prefix of I, and we will subtract from prefix of j, I think, because what is j? J is now 2, and your prefix of 2 is this. So okay, so prefix of j plus 1, right? Prefix of j plus 1, because your j plus 1 is actually 9. So from that we need to subtract, right? So prefix of j plus 1 minus prefix of I. So this will give you the prefix sum, and you don't need to calculate the sum separately, right? So in that way you can do it, but then also it becomes O of n square because there are two loops, right? So what other idea we could use? So the final solution is based on two pointers, so we will use two pointers to solve this problem. How do we do that? So let's erase this. Do I need prefix sum? I don't need prefix sums now. Rather, what I can do is I can just take my I equal to 0. I can just take my I equal to 0, and I can also keep my j at 0. I don't need to go to I plus 1, right? I'll just keep my I at 0 and I'll also keep my j at 0, and then I'll see while my I is less than n, right? Because I definitely needs to be less than n, because the extreme is n minus 1, right? So while my I is less than n, what I'll do is I'll I'll keep on incrementing the sum. Okay, so I'll just do sum plus equal to, what happened, wait, okay, so I'll just do sum plus equal to a of I, right? And so like what happens first, if for this subarray, let's say it becomes 2, and here I'll actually make a while loop which will basically check that if your sum is greater than the required sum or not. Like in this case the required sum was 7, so I'll just check if that is greater than or equal to or not, right? So like in this case it was not, right? Because 2 is lesser than 7, so there's no problem, right? So then what I do, if it is, so this loop doesn't work because this loop has the condition that while sum is greater than equal to x, right? And your x is basically 7, so this loop doesn't work. So therefore I go again back here, and I'm incrementing I, so right at the end I'll write I plus plus, right? And then I goes here, and then I'll add this again, so your sum plus equal to a of I do it again, right? So basically now your sum becomes 6, right? I'll just erase it, a bit. So now your sum becomes 6, and then if you see, still my while loop doesn't work because it is still less than 7, like it is still less than 7, yeah. So now my I again increases, and then I go to this, and now my sum is 7, right? So now it is exactly equal to 7. So what I'll do in this loop, while sum greater than equal to x, as it is equal, what we do is, first thing that you need to do is you need to decrement, like first thing that I do is I increment my j, so I take my j pointer here till the time my sum is greater than equal to x. Till it is greater than equal to x, I'll increment, and before incrementing I'll check every time that if my sum that I have now, if that is equal to x, if that is equal to x, right? If that is equal to x, like in this case it is 7, right? So then I'll take a count variable, and I'll do count plus plus, right? I'll like in below this I'll do count plus plus, right? And here I'll do that thing that I'll just increment j, and from sum I'll deduct a of j, right? Sum minus equal to a of j. So now you can see as I've done that, and my sum is now 5, so it is not greater, right? So my while loop stops, and now again my I has incremented, so now my I is here, right? And it has again taken sum plus equal to a of I, and it is again 7, right? As it is again 7, so it will again enter that while loop, that sum greater than equal to x loop, right? And then it will again find that it is equal to 7, so your count now becomes 2, right? Now your count becomes 2, and then it will do sum minus of a of j, so this becomes 3. Now your sum becomes 3, so it doesn't have a problem, right? Okay, so your sum becomes equal to 3, and now it is not greater than x, so it again gets out of that j loop, and now your I is here, and it is again added, so now your sum is equal to how much? 10, right? So now as your sum and your j is here, so as your sum is equal to 10, so it again enters that j loop, and your sum is not equal to 7, so your count variable does not increase, your count is still 2, and then what happens, it decrements this, so now your sum is 9, and it is still greater than equal to x, so it is still in that loop only, and then it will again check if your sum is equal to x or not, so your sum is 9, so it is still not equal to x, then it will again decrement this, So then now your sum is 7 after decrementing this one, a of j, right? So and it will again check. So now still your sum is greater than equal to x, and this time your sum is also equal to x. So your count again increases, and now your count is 3, right? And then it will decrement this. So now your sum is 0. Now your sum is 0 when it is decremented sum minus a of j, and then it will simply increase I, and then I becomes greater than I becomes equal to n. So I is not less than n anymore. So therefore uh, your answer is 3. I hope you have understood the algorithm. Thank you.